Welcome to the first of a two-part introduction to flipped learning. In this first video, we'll answer the question, what is flipped learning? Well, if we think of traditional as the teacher presenting the lesson in class and the students doing homework at home, flipped can be thought of as a lesson now being done at home using online resources provided by the teacher, then doing the quote-unquote homework in class with the aid of the teacher or peers. In some respects, flipped learning is really nothing new. For years, teachers have been asking students to engage in new content at home before it was ever covered in class. English teachers have asked students to read a novel on their own time. Class time is then spent on drawing out themes and symbolism rather than rehashing the plot. Law students have long been required to study the material before class in preparation for Socratic method questioning by their professors. What is relatively new, however, is that technological advances have allowed us to deliver the content and even provide formative assessment in ways never before possible. Let's explore that a bit further by describing how flipped learning works where I teach. Let's start with the individual learning space. In other words, what students are expected to do at home. Just about every night, students will be asked to do two things: online lessons and exit tickets. First, they'll need to complete one or more online lessons. These are relatively brief lessons, around 10 minutes. Most lessons will either be a video, like the one you see here, or a slideshow, like this one, where they click to advance the material. Both formats are meant to be interactive. In both cases, students are frequently asked to pause and answer questions. To aid in their note-taking, they'll have a lesson notes template. For example, most what you see here on the screen will already be in their notes, so they don't have to rush to get down every word and sketch every diagram. What they do need to do is to thoughtfully engage the material, and when prompted to pause and solve a problem, to do just that, and fill in their own answers, and only then move forward to check their work. The second thing each night, students need to complete one or more exit tickets. Exit tickets are brief formative assessments of no more than a few questions directly tied to the content of the lesson they just did. Exit tickets are so called because students should not consider themselves finished with a particular lesson until they've submitted all their exit ticket answers. More on exit tickets in a moment. So, before coming to class each day, in their individual learning space, students should have completed 1, the prior night's lesson or lessons, and 2, the corresponding exit tickets. The total amount of time spent should be in the 30 to 40 minute range. It's worth noting that I developed all the materials for the course in a manner that has been demonstrated as successful in the science education literature for flipped classes in engineering, advanced chemistry classes, and even general chemistry, a class very much like this one. Let's now describe what happens during the face-to-face class time, or what one might call the group learning space. Generally, class time will be broken into 3 segments. First, as students enter the room, a catalyst question will be waiting for them on the screen or the board. This is a brief question related to the previous night's lesson. Their job is to get right to work and answer the question as soon as they get settled in their seat, even if other students are still entering the room and class hasn't formally started. Now, while they do this, the teacher will go around the room doing a spot check of everyone's lesson notes from the previous night. Second, after going over the catalyst answer, as well as making a few announcements, we'll have a 10 to 15 minute traditional lesson and discussion. And it's the results of the exit ticket that will frame the discussion. Before class, the teacher will review the results of the exit ticket and then tailor the discussion to address the areas of greatest need. Third, the bulk of the class time will involve small group or independent problem solving. Students will work on problems similar to the ones they'll eventually see on quizzes and tests. And the teacher and their peers are right there to help them, one-on-one if needed. And it's that point I'd like to leave you with. The biggest benefit of flipped learning has nothing to do directly with technology. The most compelling advantage, in my opinion, is the enhanced face-to-face time that occurs in the classroom, the group learning space, both between teacher and student to student. Much more on the benefits in part 2. Please take a second to read the quote you see here. It's been my experience that the flipped model has provided me with far more opportunities to help students unpack content and come to a deeper conceptual understanding. Well, thanks for listening, and see you soon for part 2.